In this question, we're given the graph of the variation of the force as a particle moves from a position x equals 1 to a position x equals 4 meters. And we want to find the work done on the particle by this given force in the graph as the particle moves from 1 meters to 3 meters. So we want the work done here. Now we know that the work done is equal to FD cosine theta, and we also know that given this graph which is F versus X and it shows the displacement, then this is going to be equal to, the work will be also equal to the area under the graph. So if we want to find the work done from this graph, all we have to do is just look for the area under the curve between x equals 1 to x equal 3. And basically we can count the squares that we have here. So we count the squares that we have under our graph. We approximate this these squares. So the work will be equal to the area under the curve between x equal 1 and x equals 3 meters, which is equal to 11.5 squares, and the area of these squares will be 11.5 times, let's look at the value for each square. Horizontally we have here 0.5 meters and vertically we have 1 Newton. So the area of one square is 0.5 times 1 Newton meters, which is joules, and this will give us a work done of a value 5.75 joules. So this is part A. Now part B, the curve is given by f equals a over x squared. Calculate the work using integration. So now we want to find the work done by calculation. We know that the work will be the integral of f dot dx with x going from 1 to 3 meters. So this is from 1 to 3 for a over x squared dot dx. And this will give us the integral of 1 over x squared with the constant taken outside, and the integral of 1 over x squared, we know it's going to be minus 1 over x, so this gives us minus a times 1 over x going from 1 to 3 meters. Now a is given in the question to be equal to 9, so now all we have to do is substitute the values for x, and if we calculate this, we're going to get 6 joules. So this is precisely the value of the work. Of course, it's more precise than the value that we found by studying the area under the curve, because our counting of the squares cannot be perfectly precise.